Now, covalent bonding. In covalent bonding, as we discussed earlier, there is sharing of electrons. The simplest form of covalent bonding that we should begin with is between two hydrogen atoms. Now, if they are the same atom, it doesn't form a compound. Keep that in mind. When two hydrogen atoms form a covalent bond, they are forming a diatomic molecule. That's the word, a diatomic molecule. Now, the hydrogen atom, each one has just one valence electron, as we saw in the Lewis symbols in the earlier video. So there is one dot here and one dot here. What happens is that there will be the sharing of those two dots or those two electrons between the two, bringing them together. What won't happen is depicted here, which is one hydrogen atom and another hydrogen atom basically combining by one hydrogen atom losing an electron and the other gaining one. This does not happen with hydrogens. First of all, hydrogen is a non-metal. To form an ionic compound, you need one of it to be a metal who is willing to lose electron and the other a non-metal who will gain electron. When you have both as non-metals, who is willing to lose an electron? Why would this hydrogen want to lose an electron? It has the same characteristics as this hydrogen, so both of them equally want electrons to form a noble gas configuration. So under normal conditions, and chemistry is about normal conditions, this kind of reaction does not happen. How do we show the sharing of electrons which does happen? Well, here it is. So hydrogens, each one with a dot, one valence electron, coming together, and then we place the dots one over the other between them. And this is the sharing of electrons. This hydrogen can say that I have two electrons. And why? How many does it want? It doesn't want 8, it's an exception. It wants to look like the noble gas closest to it on the periodic table, which is helium, which has only 2 electrons. Similarly, this hydrogen can also say I have 2. And that's your covalent bond, the sharing of electrons between them. Now, what exactly is the attraction between them? Because in the case of ionic compounds, it was the negatively charged ion attracted to the positively charged ion. In this case, it's more like this electron is attracted to this proton and this is attracted to this proton. That brings them close together. Now, there is a certain thing called bond length that's involved here, which we'll not go deep into yet. But if they keep on coming closer, that's when there will be repulsion between the nucleus of the both atoms because they will start to merge into each other. But if they go away, then the attraction brings them together. That's what keeps them together, the attraction between the two. Here is another example of a covalent bond. This one is also not a compound but a diatomic molecule of fluorine gas. Please memorize this list of 7 compounds: hydrogen gas, nitrogen gas, oxygen gas, fluorine gas, chlorine gas, bromine liquid, and iodine vapors. Those are the 7 compounds that we have which form diatomic molecules. Now, fluorine example is given here. Fluorine has the electron configuration 1s2, 2s2, 2p5. 2s2, 2p5 is 7 electrons, shown here 7 dots. And when they combine, you have these two in the center that are being shared. The ones that are being shared are always placed on the center between them, whether it's 2 or more. And here you have the unshared or non-shared electron pairs. Notice how there are electron pairs everywhere. How many total electron pairs do you see in this structure? Well, 1, 2, 3, 4, 5, 6, 7. 7 electron pairs. How many of them are shared electron pair? Only 1. How many of them are non-shared electron pair? 1, 2, 3, 4, 5, 6. So that's your fluorine-fluorine covalent bond. Now here we look at more complex examples and we will learn how to make our own versions of this with other molecules for which it's not provided to you. How do we form water? Water has the formula H2O. How do I know that it has covalent bonds and not ionic? Well, in water you have hydrogen, which is a non-metal, and oxygen, which is a non-metal. Whenever two non-metals are involved, nobody will be willing to transfer electrons because none of the two will have low ionization energies. Both will have high electron affinities. So both will only come together by sharing electrons. So here two hydrogens and two oxygens. One hydrogen on each side goes and shares its electron with this oxygen, which has 6 valence electrons shown here symmetrically with two single dots on each side. Then everyone has 8, well, except hydrogens which only want 2. And if you count the electron pairs around oxygen, it has 8 as well. Okay, how many unpaired electron pairs are in this structure? How many unshared electron pairs are in this structure? One unshared pair up here. How many shared pairs? 3 of them. And how many total pairs? 4 pairs. Here is an example of a molecule called methane, which is formed by combining one carbon with 4 hydrogens. And you can see the covalent bonding. This is the Lewis symbol for carbon with 4 dots for 4 electrons, and the Lewis symbol for hydrogen with 1 electron. And here is where bonding takes place with sharing of electrons. Now we will talk about something called the polar covalent bond in the next video.